Welcome back, everyone, to another episode of Adventures in DevOps. And because I'm here all by myself, I've brought as a small consolation another fact. So this one's security related. Google itself is being used to spoof login attacks. And this is because they made some mistakes with their custom domains. If you're running a website, you can actually run it on a Google domain. And so I'm here to say, like, if you're not already offering passkeys with your solution, it's now more critical than ever, realistically. And if that's something that anyone needs help with, I guess you know where to find me. So today I brought in Ang from Observe Inc., and he's the head of engineering and was previously a founding engineer for the company. We're hoping to really get into something interesting, which is not just all about observability, but really how they built a platform to scale. So welcome, Ang.
Thanks for having me, Warren.
We've actually had a bunch of experts in observability in the past who focus on different things. So there was a previous episode with Adriana Villela and all about OTel and building self-healing systems with Silvan Kalechi. So if anyone's interested in deep dives in those topics, you know, we've sort of investigated them, but I'm really interested in the observability at scale perspective, because one of the things that's always really caught me off guard is just how much data comes in from the customer systems into a third-party tool. So if you're doing logging or collecting metrics, it's something that there's just a lot of data being passed over the wire.
Right. And, machines are very good at generating a ton of data. You have seen like news, like for instance, OpenAI is dealing with like more than 1 petabyte of data per day. And that's, not that rare. We have seen, among our customers, like multiple cases where people are sending, hundreds of terabytes of data per day, even like a petabyte. So, how do you kind of store those gigantic amount of data, at scale cheaply, and also how do you process them and how do you...
So, petabyte, megabyte, you just stick it in S3, right? Problem solved.
Yes. So cloud, definitely, like the modern cloud is very magical in terms of that. Even if you consider like just dumping everything into S3, right? There is still the challenge of, how do you organize your data, right? Like do you want to do like columnar store? Do you want to do row store? And if you put stuff into S3, like how do you index them, or do you even index them, right? So many of the modern data warehouses, like Snowflake or Databricks, they use a different scheme, right? They don't index their data. They partition their data, and then they somehow cluster their data. As an observability vendor like ourselves, we definitely do a lot of these kind of custom clustering and custom data modeling to make sure that people can access these data at scale.
So like maybe still some secrets here. Like what's Datadog and Databricks and Observe Inc.? Like how are you storing the data? Are you using S3 for some part of this, or is it you have your own like virtual machines where you're running your own sort of custom database, or some database provider that you're managing there to the engine, like on your own infrastructure to actually store it?
Yeah, very good question. So, when we got started, that was like around 2018. The basic idea that we had was, hey, around that time, data warehouse was kind of booming, right? You have like Snowflake and Databricks, and you look at them and you thought, the kind of the generic, the relational execution engine they built on top of, S3, essentially EC2, is actually pretty generic. Separation of computation and storage, right? So you can store your data in S3, but then you can basically essentially spin up EC2 clusters to crunch this data on demand. If you just want to store the data, if you don't want to run any query, you don't have to pay for all the EC2 machines to be online all the time. Observability data vendors, like Datadog, they usually have their own kind of proprietary execution engine. Being a startup engineer, you feel like, hey, we probably don't want to spend the first 4 or 5 years of the startup building a database from scratch. We more wanted to provide values to our customer, right? To solve real use cases.
I mean, it's interesting bringing that up, because I actually think that this is something that Charity speaks a lot about in the past, actually, when she built Honeycomb, was they did actually roll their own database. The thing that kept on coming back is like, no, it was definitely a mistake.
it went against all the instincts of me as an engineer, right? Like I would love to build a database from scratch. If we really want to build a solid database from the ground up and support all kind of functions, yeah, it's going to take years.
It's going to be a challenge to do it better than the ones that are out there today already. Like you pretty much would have to first employ database architects who have done this many times before, and then you spend all of your time and effort building up something that isn't even going to be really the core competency or competitive advantage on what you're selling as a product. So what did you go with off the shelf then?
Yeah. So we went with Snowflake.
Okay.
So Snowflake. There are a bunch of other kind of non-technical reasons of going with Snowflake by using a lot of the mechanisms they provide. For instance, Snowflake allows doing auto clustering of your data. Snowflake obviously has excellent semi-structured data support. So that's also a thing that we leverage a lot in our solution. So Snowflake obviously, is built on top of S3 and EC2. So, you can say we kind of also consider that as, building on top of S3 and EC2. And when you ingest data into like Snowflake, pretty much, S3 in general, you're probably looking at something like 30 seconds or so that is the fact, right? Because you're dealing with terabyte or petabyte of data, right? But, for some of the use cases, you probably want better, right? Like if you want to do real-time monitor or you want to do some very real-time troubleshooting, right? You would want something that's seconds or even milliseconds of latency.
Okay. So did you build a proxy layer that sits on top of your own Snowflake account that has the data from customers being filtered and then being routed to the appropriate tenant inside there? And is it just passing the data off, or is there something happening in your architecture that's before the data is actually entering?
We obviously use Kafka and stuff to queue the data before they get into Snowflake. We are doing a little bit of processing in that part of the system. Not a whole lot right now. I think they're mostly about filtering the data and doing some kind of data shaping. We also do authentication, and there are different endpoints that we support.
So I've never found a good reason to use Kafka in my experience. And the one bad time that someone wanted to use it in my proximity, I had vetoed it because at the time it still required running Zookeeper, a third party, another tool in order just to manage it. I think that's finally gone away, but I'm actually curious what the need would be at the edge in order to process it.
I think for Kafka, it's mostly just for queuing because, Snowflake is fundamentally a batch-based engine, right? So
okay.
I think right now it's getting better. They have some kind of native support for stream ingesting data. But I think back then they only support ingesting data in batches. So basically you need to upload the data to S3 and then you have to call Snowflake, and then the Snowflake would, find those data and upload those batch of data into their own S3 essentially. But then, we have to handle streaming data from the customer, right? So we need something in the middle to convert the data from streaming to batch. So, and to absorb any kind of, burstiness from the customer, because, when Snowflake uploading stuff, it's a pretty much constant throughput, right? But when the customers, throwing data at us, it highly depends on what the customer is doing right now. Like we have these, for instance, it's video, intelligence customer who's doing kind of video analytics. Yeah, fun story. They were doing a video analytics stuff. And then back then it was the World Cup season. And whenever there's a game showing out, you can see the customer's traffic basically spiked. Still, at that point, we were not super good at handle some of those spikes, and would always have an incident or some thought that we need to deal with on Sunday. And I'm like, yeah, it's definitely one of those World Cup incidents that this customer is jamming us with. So yeah, so we kind of need the Kafka to absorb those large bursts of data and to smoothen it out. If you ask me, do I love Kafka? The answer is obviously no.
Yeah, so it sounds like you're pretty much having that run on the virtual machines in AWS that you control for handling the load. Now, I'm curious then, Was there ever a consideration to use something like Kinesis?
Yes. So we definitely have thought about it, but I think eventually we decided to not get super tied to the AWS ecosystem, just because this is a pretty practical concern, right? Because people will ask us to provide a GCP or like a Azure deployment at some point in the future. I think right now we already have kind of a GCP deployment, and kind of porting that between different cloud is going to be a challenge.
Interesting. I know what we do in those circumstances is our main workloads are still running on AWS, but when we need to have connectors into other clouds, we will use like GCP's Event Arc, and I forget the thing in Azure to connect in and stream our analytics that we see inside our product to back to our customers' implementations. And I can see the opposite happening. I don't know what the corresponding things are to Kinesis. I mean, that's been a much better sell internally for us because we could more utilize the advancements that the cloud providers are making rather than trying to manage all the non-serverless aspects of spinning up really like EC2 machines and then deploying complicated technology on top that no one internally is an expert on, just to deal with the load. I mean, I always found Kinesis interesting. Like I've always hated it as a product. If you're not in AWS, anyone that's listening, there's two forms of Kinesis. There's like Firehose and then like streams, and I can never remember the difference between what these two things are. One of them does sharding and is for like pulling data, and the other one's like for pushing data and piping it somewhere else. But it's always really interesting to me because it seems like even at small volumes of data, it may work fine. And then I get the questions like, well, how much data can you actually funnel at it? And I'm sort of curious, like, do you actually know like how much like the total customer data that's coming in through your platform is?
I don't have a concrete number at top of my head, but I can say probably multi-petabyte per day of data coming, probably more than 10 petabytes of data per day.
I honestly have no idea if that's a lot or not.
Yeah, I mean, it kind of boggles the mind that, how much, crap people generate. Maybe I shouldn't say that as an observability vendor, but the sheer amount of data that comes in, and you get these like billions of rows of logs, every few seconds. Do people actually need so much data coming in from their system? But the truth is, I think if you kind of filter them down, and if you have kind of a pretty flexible pipeline, right, you allow people to kind of branch off the data and clean it up and to transform them into a shape that they can query more easily. That actually brings a lot of values for these customers, right? And it also has kind of a little bit of benefit of, hey, I don't have to drop data, right? So I don't have to pre-select, pre-choose what data might be valuable to us, down the road or not.
And I say recently, and I really mean, I guess the last 6 years or so, I did see a bunch of startups that popped up whose only goal was to basically figure out and drop data before it entered Datadog, to avoid getting the cost hit. And I'm wondering how you've managed to overcome that. Is it a matter of you are not charging so much, like you're basically charging like a lower flat rate that's closer to the infrastructure cost for storing the data, and then it's some sort of usage-based pricing off of the queries or something else? Like how did you make that trade-off be financially effective?
Yeah, that's a great question. So there are multiple aspects of this. So like for one, you're definitely right that we don't try to make a lot of money off like storage cost. I think the same is true for Snowflake. Basically, we just pass on the infrastructure cost of S3. The other part of this, we don't use index and all that for a lot of our data. So ingestion, comes pretty cheap for us. And we are also very good at kind of dynamically kind of scaling up and scaling down the computational resource, the usage-based pricing, right? So that by itself is a very interesting topic. You would think, usage-based pricing is a good idea. I think it worked very well for the business intelligence use cases, like, Snowflake, for instance, does very well for their usage-based pricing. But it actually didn't work very well for our customers because, for observability, usually, you work with a budget and you hate surprises, right? You hate that, hey, why this month my usage bill is, through the roof. You want the vendor to say that, hey, I'm only going to charge you so on and so forth. The nicer thing is, as a vendor, right, we also have some wiggle room of saying that, hey, if you pay us so much, we can start kind of throttle you if you are way over, in terms of your usage, right? It's kind of like the mobile phone data, the mobile kind of data plan model, right? So if you're over your limit, you can still use your phone, like you can still query data, but it won't be like super fast, right? So you can still get your job done. So that offers a much better kind of off ramp.
I mean, that's really interesting because we actually saw the complete opposite thing when it came to our domain. So we offer like login and access control for our customers. We generate JWTs for the applications that our customers write. And the ones that have come to us and said, we don't want usage-based pricing, we want to pay like per number of users or whatever. And I'm like, what do you want to happen when you go over that number? Option number one, user can't log in. Option number two, you may say you want consistent charges, but that means you are waiting until the end of the year, basically, or end of the month, depending on their subscription plan, to get the charges anyway. So is it better to wait till 6 months or 7 months to the end, whenever the end of the year is, to actually feel that hit, or better to get it per month during the subscription? And realistically, they're like, oh yeah, no, actually that's bad. Like
Yeah, obviously, yeah.
We don't want to wait to pay, and we can't have you degrading the experience for our users. And I'm like, okay, well now you know why our infrastructure thing charges in this way. I mean, I can imagine you're not necessarily in the critical path of the end user's applications, although yes. I can also, on the flip side, see the value that you're providing. So you mentioned like really driving some business-specific use cases. So not necessarily just having the logs available or the metrics on like whether or not there's uptime, et cetera. But I'm really curious what you've seen there from a like competitive advantage for your customers who now have access to basically all of the data from their platform that if they had used something else, they would not have retained.
There are a lot of interesting stuff that we have seen our customers doing, right? So for instance, many customers would, kind of do, using their logs and, tracing data, they can build kind of high level kind of customer journey, by doing some kind of aggregation, right? So you have, these different events belong to the same user, right? We want to aggregate them and you form a session that, similar to the things that you would do with like a web analytics tool, like Google Analytics and so on and so forth. But you can kind of customize and you can decide what are the events that belong to the same session and you can aggregate them, right? So that's very common. Like people do that all the time. And many cases people can also join with their business data, right? Like, hey, I have this log message, right? It references, customer 1, 2, 3, 4, 5. Right? That's just an opaque ID. How do I know, who customer 1, 2, 3, 4, 5 is? What customers are affected by this particular incidents and, by how much? The margin of the customer of this month, right? We can actually calculate that all the way just from logs data. Yeah, we also kind of ingested a lot of the financial data into our system as well, so that we can have like the sales data and all that in one place. What happened? Can we exactly pinpoint, like for instance, the one incident that caused us to have to burn some extra computation for that customer? Then I would explain this 10% margin loss.
That's interesting. I mean, if I understand you correctly, there's actually scenarios where they're potentially using Observe to store like almost as their customer CRM and importing the data in from wherever their other systems are, hopefully not Excel spreadsheets, but could be, rather than funneling the data out of the customer specific data, like, metrics or usage patterns for the whole tenant or customer account into, say, whatever the sales or customer success organization is doing. So this could be like, unfortunately, like a Salesforce or something like that. So it is interesting to hear that some people are actually utilizing the ability inside your tool to make that happen. Because from my experience, these things like happen in the Tableaus of the world, and anyone who is technical in any way always hates these tools. Like It was never the time where where I saw an engineer jumping into Tableau or Looker and was like, wow, this is like the best experience ever. That never happened.
Yeah. Yeah, I think for us, we like our internal use cases are definitely kind of biased, for obvious reasons.
No, I don't believe you.
Yeah, but I think one thing I would point out is, because when you build observability platform, right? So essentially, you are trying to build, from a technical perspective, you're trying to build a pretty good streaming engine, right? Because the data is always kind of streaming. Compare that with the traditional ETL kind of system, right? The ETL, you have to specify, hey, how often I want to run this pipeline. Is it by day or by month? You have to think about that, right? So it's like it forces you to think this in a batch kind of mode. And you also have to think about, what if this job failed? I have to retry it. I have to stitch the data together and so on and so forth, right? But if you build a kind of a streaming first system, right? The system kind of take care of that for you, right? So you don't have to think about, hey, how often I want to run this job. The system kind of decides, based on the incoming volume, do I chop it up into 1 minute fragment to process, or do I chop it up into 10-minute segment to handle? So if you have this kind of capable streaming system, you naturally wanted to kind of do more use cases on top of it, because sometimes it's easier to express what you want to do.
So if there was someone out there that thought they had a similar need to handle such large amounts of incoming data over the API, I mean, you're obviously using Kafka here to handle some of the load before the systems which aren't designed to be either idempotent or have the amount of scale that you need. I'm just interested in what the whole interaction is here. Are you providing custom agents for your customers to run on their virtual machines, or is it an SDK, or is it just a matter of exporting OTel compliant data out? And on your side, are you using something to handle the streaming, or is this custom technology that you had to build because, I don't know, XYZ just didn't cut it as far as both having the functionality and also the reliability that you would need in this domain?
Client side, we basically do pretty standard stuff. We do have our own agent that you can install, and it will collect the data. And we also have, standard endpoints, like I said earlier, OTel and all that. You can, if you have OTel instrumentation already done, and you can just point your OTel library to us, and then we'll take it very easily from there. On our backend, we do build a lot of custom things for stream processing. So because Snowflake itself is not a streaming engine, right? So Snowflake only offers storage and compute, right? And Snowflake does offer some form of materialized view supports, but we didn't use those mostly because the pipeline that we are building is kind of interesting. We want to have a lot of flexibility for the user to do streaming data. But for observability use case, you can imagine a lot of cases where I have already collected a lot of historical data, right? I would want to reprocess those historical data and using my new pipeline, right? So that's one of the main reasons where we build our own kind of streaming system sitting on top of Snowflake, right? And, just to add kind of another little bit aspect of this is, we also didn't use the existing materialized view solution provided by Snowflake, because that allows you to backfill, because, you can just start a new view and you let it materialize, but then it's going to materialize the whole thing, right? And imagine the cases where you have already collected historical data for a year, right? And, just reprocessing that whole year worth of data is going to be very expensive and very time consuming. So,
this making me think, because this may be the first time I've actually heard someone utilizing Snowflake as their as a core component to their architecture. Is this an expected use case that Snowflake supports, or is it? I mean, is there a concern here that Snowflake will be no, I'm sorry, you can't embed this as a part of fundamental product if you're building something that sort of competes with it in any way? Is that a concern at all, or is it just no, this is sort of supported, and there are actually lots of companies doing that?
The answer to this is kind of there are different layers of this. So I think from the business standpoint, I think Snowflake wants to become kind of a platform player, people building application on top of it. I think to that end, I think the businesses are pretty aligned. So they would like people to like us to kind of having a deeply integrated application running on top of Snowflake. But with that said, we are also pretty unique in the ways of how we use Snowflake, because your usual data application on top of Snowflake would be, hey, I offer some custom UI to query the data that have already been stored in Snowflake. Anecdotally, because we run a data pipeline like in a streaming fashion inside Snowflake, we are accountable for like over 2% of Snowflake's query at this point.
Wow, that's quite the impact there.
Yeah, so we help discover a lot of bugs, obviously, in their system. So we have a kind of a love-hate relationship with their engineers. So on one hand, they like us because we help kind of stress test a lot of aspects of their infrastructure. On the other hand, I can only guess that we cause some sleepless nights for their on-call engineers.
You're lucky in this way. If it's good to evaluate the platforms that you're utilizing before making a decision on how you're relying on them, because if the fundamental direction that it's going, the particular product you're using or DB engine or whatever third party is different from their expected usage, you could run into, not just downtime, but really just fundamental limitations at some point where they're like, well, I'm sorry, we can't help you. So I guess in that way, you're lucky, but I can also understand the flip side of it being so critical, like not just for a single customer, but basically your whole business now, when there's an issue with Snowflake. And I don't mean like an incident, but just realistically finding an unknown edge case that isn't supported, like, oh yeah, we're hitting the limits of the throughput that is available here because, I don't know, Snowflake never imagined that there'd be so many coming in through like a single account. Or another problem that we see often is like the customer of a customer issue, where it's like it's easy for you as a customer of a product to add multi-tenancy, and the product you're using may support multi-tenancy. But if your customers are also multi-tenant solutions and they want to put tenants in your solution, then you're passing tenants of tenants into your provider. And it's like, it's turtles all the way down. And I can imagine not all those things may have been built out effectively. So do you see a future that is just like, well, as we grow in either scale, volume, amount of queries, or monetary value, where Snowflake no longer becomes the critical backbone for how you're storing and managing the...
We definitely took kind of a leap of faith at the beginning of the company. Could, be like a case where, or a different alternative reality where, this Snowflake couldn't handle whatever that we're throwing at it. The way I'm thinking about the future is really that, now, we have like, Iceberg and all those kind of open format for storage. Right, so you kind of can see the trend where the storage is getting essentially commoditized. Basically, there's not a whole lot of money to be made on storage, and also there's not a lot of useful kind of proprietary stuff in terms of storage format. Right, so everybody is kind of converging into these open format. So that's definitely good news for us, right? Because if we can leverage those open format, then that means we have a choice of different execution engines we can run on top. Right, like Snowflake may be one of them. Like Snowflake is very good at doing like large scale joins and that kind of stuff, right? But then if I just want to do something simple, right, something like just scan terabyte of data and doing like quick aggregation, right, maybe another different execution engine would be cheaper to run and would be more efficient, right? So I think that's kind of like the way of kind of leverage and kind of hedge our bets a little bit across different execution platforms.
No, that makes a lot of sense. And now you've reached the sort of the edge of my experience here. So there's Parquet format, which is like a columnar format that actually stores optimized data, so you don't have to repeat the property values, and it's easy to filter append-only logs, for instance. And this is like one of the most common ways in which even AWS is storing the data within S3. And then you mentioned Apache Iceberg. I know there isn't like full support in AWS yet, but I'm sort of curious, like what's the fundamental difference between these? And was the decision to use that like one particular format versus another something like a one-way door where you sort of made the decision early on and it's like that's the way you're going, at least not coupled to a proprietary format? Or is it something that you think is like pretty easy to switch out down the road because it's like an internal detail?
Or let's just say Parquet is one of the format that Iceberg tables can be stored at. Parquet, if you think about it, it's just a bunch of S3 files. There's no concept of a table, right? So from a database perspective, if I want a table, I have to know, what is the schema of the table, right? What columns it has. And I need some metadata to tell me, hey, in order to query this, this table from row like 100 to 1000, which Parquet file I should scan, right? That's essentially what Iceberg provides. So Iceberg provides this metadata to connect the concept of table with the raw Parquet files that you store on S3. If you simplify, really, Apache Iceberg is nothing more than just a bunch of metadata files that you store alongside of your Parquet files, right? And I think that the good thing about Iceberg is, it offers capability of doing what's called pruning on your data, right? So, for instance, if this Parquet file the value is between 100 and 200, right? And if I have a query saying, hey, I want to filter down the data to anything with a value greater than 200, right? And you know that this Parquet file will never contain any rows that would satisfy this filter predicate, right? So you can choose to not scan that Parquet file at all, right? So Iceberg basically offered this way, these metadata for the query engines to proactively prune out these useless Parquet files and to make the query efficient. So that's also a pretty kind of interesting kind of enterprise use cases, because many of the enterprise customers, they are already thinking about kind of building a data lake, right, using these open format like Iceberg, because they also don't want to be locked in by all those vendors, right? So when we comes in, we are also kind of yet another kind of data vendor, right? And they will be like, hey, could you also expose, all those observability data I have ingested into you through Iceberg? So, they can actually own those data, and they can, do more things with those data. And that's also kind of like an opportunity for us as well, because, if we build our stack on top of Iceberg, and then exposing them to the customer also becomes a lot easier.
So wait, like ingress into S3 is like free, right? But then if they're actually exporting the data from your platform, then that's gotta, especially like a large sum, that's gotta build some costs, right? And
yeah, so the point is they don't have to, right? So they can basically choose to give us their S3 bucket. Right, so we basically directly ingest data into their S3 bucket in the Iceberg format. Yeah, so in that way they truly own the data, right? So the data, all the data is in their bucket. They have access to it, but we are basically one of the applications that sit on top and operate on those data.
how do you go about securing access to a whole bunch of customers' S3 buckets?
Honestly, we haven't completely thought out that story yet. I think everybody is kind of trying to figure out how to do like essentially storage integration. Yeah, so I think right now we just use standard like AWS policies. And
You mean like IAM or like just bucket?
yeah, IAM, and then there's a specific way of doing this kind of cross.
Yeah, the trust policies between the
It's trust
IAM.
policy. Yeah.
I mean, it's always an interesting question for me, because like if you're just doing this thing sort of one off, or I think the canonical is like you're in some sort of AWS management account and you're logging into a whole bunch of organizational accounts, it's like straightforward. But as soon as you're in this weird position where you need to start accessing customer accounts, the concept of how do I actually secure this process starts getting more and more complicated. And like, how do we actually store the data for doing the access, not even the actual data, and making sure like customers can set that up correctly, because there's not like a straight, like I still want this. And if anyone from AWS is listening to this, like where is AWS OAuth access to AWS accounts? Because that's exactly really what I want here. That would be like solve a lot of problems with getting the trust policy right, getting the customers to actually enter it correctly. It's interesting because we actually do have a sort of for Authoress, we have this OAuth hack that we have an application in the serverless application repository in AWS. So our OAuth, instead of them logging in, is they go and deploy this application to their account, and it like automatically configures everything. And
Yeah.
the first time is sort of this weird edge case where we don't know which account it is. They haven't maybe not logged in, and so it doesn't necessarily work out of the box, which would be really nice if they streamlined. But yeah, the cross-account access with the external trust policies, like it's not the most customer-friendly thing.
Yeah, might be incentivized to solve this problem because they are the ultimate platform, right? They would want like
I have a lot of thoughts here. The one that I keep coming back to actually is I wonder if they're actually de-incentivized to do this because it opens a new target for attack for malicious attackers to come in and fabricate applications. Take your company for instance. What if someone threw up a fake Observe page and said, "Oh yeah, you need to just send someone an email, say, hey, your data, whatever, is going to expire. Your connection is going to expire. You need to go click on this link and click approve." In AWS, and then they get redirected to AWS. There's a screen there that says, hey, Observe wants to access your data. Do you click approve or not? And you click approve, you don't look at the permissions there, and the permissions say like full admin access to the entire AWS account, and it's just good to go. And because people aren't reviewing what shows up in those screens, and that's actually the fact I threw out at the beginning of the episode, is like literally the same problem. It's someone's making a phishing page, and people can be phishing this way. So I don't know there's a solution there, honestly, and that's why I can sort of understand not to do this. However, my retort is going to be there's already CloudFormation templates, and there's already the applications in the service application repository, which means there's already ways to phish people into giving out full access to their account by clicking on a bunch of buttons without actually needing to enter their username or password, or God forbid they're actually having a password for AWS in the first place, using their passkey to log in and authenticating that way, and then clicking deploy on the CloudFormation template. That's still a problem. So I'm not buying it. Yeah, I agree. AWS platform to rule them all. You would think OAuth support would be something that it has, and it just doesn't.
Yeah, I think I also can understand it, but I think they are being like with like Iceberg and stuff, right? I think they're gonna become the de facto data platform for everyone at some point, right? Like if everybody's putting their data on S3 directly through the Iceberg format, then you will have all those use cases of like sharing data around and like sharing data with your application and all that kind of things, right? So hopefully they can get their stuff together and actually build something.
They just came out with, I think it was like last year or so, they came out with S3 tables, which it's them making, it's nice to see that there's still some improvements being made to S3 over time, because it's not the best user experience. It's not even the best developer experience. So, there are things left to be desired there. I mean, my personal pick, if I had to say any one, is just like all those bad security features, like just default remove them from the console. Like no one should know about being able to make a bucket public. Like there's never a reason in today's story to ever have a public bucket. And on that same token, like I want to be able to name my bucket whatever I want and not like have to worry about conflicts with other
accounts. The conflict thing is so bizarre.
And I'm just like, I don't know what it's going to take here, but knowing AWS, just come up with like another replacement service, call it S3 Prime, S4, and just honestly, private blob storage. That's really all I need, and make it hook upable to like literally the exact same API. The only thing that has to be different is just cut out all those things that are these tons of footguns, right? Like especially bucket name squatting is a huge one. Anyway, you can see that I have a whole rant on this, so maybe I'll stop there.
We obviously found out Snowflake is pretty good at some things, but also pretty bad at the other things.
What's that like number one bad thing?
So you would have we have this like constant battle with Snowflake in terms of how their optimizer optimizes the query versus our kind of optimizer optimizes the query. Like many cases, if you do like a join, right, like, the ordering of the join kind of matters a lot, which side you put as the build side, which side you put as the probe side. And in many cases, it's like, like Snowflake, could you just like let us decide what is the join orders? Because we know more about the data than Right, but then you thought the Snowflake would join the other way, but then Snowflake would actually swap it and ruin your entire efficiency. So we would always wish like Snowflake could just provide us with an API for us to just, send them the query plan. Just don't change it. Just run it as is. But obviously that's not something that they are willing to do.
That's really surprising, actually, because I feel like even as far back as I remember, which isn't that far, with MS SQL, there was always like you could pass it hints to the engine.
Yeah, so now they're getting better at that. So very recently, they released a new feature. I think I would like to think that we push for it, but they recently released a feature called directed join, which is kind of like similar to join hints that you can just say, hey, use this as the left, use that as the right, don't change it. But we have waited for so long for such a feature.
Well, I guess your 2% usage only accounts for so much.
Yeah.
Well then, I guess we'll take this opportunity then to move over to picks. So what did you bring for us today?
Yeah, so I bought this gadget for my kind of summer traveling. It's this like 3D. I can actually show you. It's on my desk here. Yeah, so it's this kind of like AR kind of glasses.
Okay.
Not the fancy ones like the Vision Pro or whatnot. Basically, what it does is it has like a HDMI, connector to whatever devices you have, and it has this like tiny kind of OLED projector at the top of the glass, and it just projects things into a lens, so you can kind of see things. It worked pretty surprisingly well. So it does like hat tracking. I use it for work during the traveling because I, obviously cannot bring a large monitor with me. And plugging that, I can actually get like a 30-inch monitors like floating in front of my eyes. So
you have to plug it in though. Like it has to be physically connected.
Yes, that's one drawback. But I would say that because it doesn't have any battery inside, it's powered purely through the HDMI.
Oh, interesting.
Yeah, so I don't have to charge it. So actually, the experience is better than like having something I have to bring another charger in.
Do laptops support power over HDMI?
Yes, surprisingly.
Interesting.
I was even work with my phone. Like it drains the phone battery really quickly. Though.
It's like there's the battery.
Yes, but at least it works. Yeah.
Wow, that's amazing. So, like, what is the company? What is that?
Oh, it's called X-Real. X-Real. I think the one I got is called X-Real Pro, One Pro or something like that. Yeah.
Okay. So I should just like get rid of my monitors. How much is it?
Like a $500-$600, I forgot. Yeah, way cheaper than like a Vision Pro. Yeah.
I see. So I should just get rid of my monitors, switch it over to this, and like walk around with like an HDMI cable coming up.
It's not the most kind of like socially acceptable attire out there, but
the interesting thing is like I'm surprised that they didn't have like a battery pack, honestly, connected with like rechargeable batteries that you could like have in your pocket and then have a remote HDMI, because I feel like that would allow you to walk around with it, but having to take the glasses off in order to perform other actions, I don't know.
Yeah, I think with this, I kind of see, there's another way of doing kind of AR that's not the Apple way, and it kind of also works.
Yeah. So this is I'm going to speak at a conference, and instead of bringing my laptop, I'm bringing my phone and my AR goggles. Okay. So for me, what I brought is there's a movie that I just really like, and every once in a while I'll rewatch it. And so recently I had a rewatch of The Shadow. It's a 1994 with Alec Baldwin, and it was originally made after the radio show from the 30s. And I don't know, there's just like so many great quotable things in it. And actually, it's if you haven't seen it, it's have you seen it?
I haven't.
It's the original inspiration for Batman. So it's like Batman didn't come from nowhere. It was actually the Shadow with not with Alec Baldwin, but because that was much later, but. It's great. It's like, just imagine Batman with guns, and also in the movie he learns like telepathy and telekinesis. So I mean, it's just honestly, it's like a much better Batman. It's like everything Batman wishes he could be.
Yeah. Like I never understand why Batman is not allowed to use guns, but I guess.
I mean, it's interesting. There was actually a really long documentary on the making of Batman the Animated Series that came out in like the 90s, and how it was like so dark And at the time, it was like the only dark animated television show. Everything else that's even remotely animated is like sunshine and flowers. Like getting everyone to sign off on like how like almost deeply depressing some of these episodes are, or like the dark drama that is now just everywhere on television, is like quite unexpected. So I can see like even the upgrade to guns is just something else. I mean, there's a lot of history about like the gun usage, or even just in canon. I don't know what the non-canon reasons are, but I suppose if you wanted guns, just go watch The Shadow. It's fantastic. I mean, it's like quality bad movie, but I mean, I actually really like it.
I will. Yeah, thanks for the suggestion. Yeah.
Okay, well then that's the end of our episode. Thank you, Eng, for coming and talking about Observe and how to build an observability platform that's gotten quite far and using such a high amount of compute and Snowflake as a database. That's been really interesting, and I hope we'll be back on next week with another episode.